Chapter 4, Measurement Systems, Units, and Equivalencies. After doing this chapter, you should know the standard abbreviations and rules for expressing measurements and basic equivalencies for the household system, the metric system, and the apothecary system of measurement. Three measurement systems are presently used in the medical field to calculate length, volume, or weight, although length is not as commonly used in the pharmaceutical field as in other medical disciplines. Each system has a unique set of measurement units that have been chosen as standards. Numbers without units are meaningless. Consider telling someone that you'll be gone for 3. Without the unit designating minutes, hours, days, months, or years, there's no meaning to 3. The U.S. customary system or household system uses measurements such as inches, teaspoons, and pounds. The international system of units, or the metric system, which is used in most of the remaining world, uses meters, liters, and grams. The apothecary system, which uses grains and drams, is an older system used in pharmacy for many years but less frequently today. All three systems, household, metric, and apothecary, have units of measure for weight and volume that are used in pharmacy, but only household and metric systems have commonly used units for length. Knowledge of the units for weight and volume in the three systems and length in the household and metric system is necessary to interpret medication orders and prescriptions. In pharmacy, length is used to measure medications that require application to the body that must be measured in inches, centimeters, or millimeters. In these instances, the means of application is usually pre-marked on a dispensing paper for ease in ensuring that the correct amount of medication is administered, such as with nitroglycerin ointment. Another pharmaceutical use of length is in finding body surface area, where height and weight are used for dose calculations. Mass is the measurement of the amount of matter in an object and is commonly referred to as weight. Metric weight is the measurement used most often in pharmacy to express doses. Most medications are ordered and supplied by the weight of a drug in solid or liquid amounts. Most solid medications are supplied in micrograms, milligrams, or grams. A few older medications are still supplied in grains from the apothecary system. Household measurements of weight are not used in medication strengths. Volume is the amount of space something occupies and is used to measure amounts of liquids. A derived unit that is used to describe liquid medication strength is density, which is weight divided by volume. Most liquid medications are described in terms of milligrams per milliliters. Occasionally, some products, such as milk of magnesia, they're still labeled with the amount of active ingredient per tablespoon, which is 15 ml. Some other specific types of medications are dose in milliequivalents, MEQ, and international units or units. Milliequivalents are used to express concentrations of electrolytes that are needed for normal body functions. For example, a Cater 20 tablets contain 20 MEQ of potassium per tablet. Units as a measurement are assigned to various biologics, which are substances made from living organisms that are used therapeutically as medications. The unit measurement is actually assigned according to a medication's activity in the body. Units are specific to each individual medication and do not relate to one another. For example, units of insulin cannot be compared with units of heparin. Measurement of these two medications are covered in Chapter 10. Most measurements need a unit to have a meaning. The one exception to this is specific gravity, which is the density of a substance in grams per milliliter, is divided by the density of water, which is 1 gram per ml. In this calculation, the units cancel, leaving specific gravity without a unit. If the density of a substance is x grams over ml, once it is divided by the density of water, or 1 gram per ml, the units cancel and the specific gravity of the substance is x. Specific gravity is used occasionally in pharmacy to calculate the weight or volume of a solution. Some of the previously mentioned measurements are used daily, whereas others may be foreign and need explanation. Household measurements and abbreviations of weight can be found in Table 4.1, length in 4.2, and volume in 4.3. So here is our tables here, which you'll find that the cheat sheet I gave you is probably a little bit more helpful, but there are some different ones on here. Household measurements are expressed in Arabic numerals with fractions for expressing parts of a whole number, such as 1/2, 2/3, or 3/4. The abbreviation for each measurement follows a number, such as 5 teaspoons or 2.5 pints. So in the household system, if we didn't get a whole number, we would express that as a fraction. So 2.5 with half written out, 2 2/3, 2 3/4. And if it's a whole number, we would, obviously write it as a whole number, and the abbreviation for each measurement, which I call units from being a chemistry major, um, you would put that after the number. Household measurements are often used in the home setting for administration of medication, although they are not optimal and should be considered approximations. Some use their flatware for table use instead of actual teaspoon and tablespoon measuring spoons, which greatly increases the likelihood of a significant error. The use of a measurement device provided with the medication by the pharmacy increases the accuracy of dosing and therefore patient safety. The household system is not used in hospital settings. So we have this table here, and it gives you some things that you should know to memory. And if you look at the cheat sheet I gave you with the conversions, you'll see all the different highlighted ones. Um, some of these I didn't have on there, but the metric system of measurement is the most widely used system in the world and the most commonly used system for measuring medications and doses because of its accuracy. Most prescriptions are written in the metric system, and most liquid drugs are administered using this system. The U.S. Pharmacopoeia considers the metric system the appropriate system for use on drug labels. Medication labels should be written in the appropriate metric units. Some medication labels include household measurements as well as metric measurements, as seen with the label for zidovudine. Additionally, some labels still contain non-recommended abbreviations, such as microgram found on the labels for digoxin and cc cubic centimeter, which is equivalent to milliliters. The metric system is based on units of 10. The basic measurements are the gram for weight, liter for volume, and meter for length. Prefixes for that base measurement are used to indicate the multiple or submultiple of the bases that is being described. There's the label for the zidovudine. The digoxin labels. Great. And then here is figure 4.3, what they're kind of explaining the different, the indicating of larger or smaller measurements. And then table 4.4, we have the metric system of measurements with their units. And then we have table 4.5, which has metric equivalents used in pharmacy. A cubic centimeter is another way to express a milliliter. 1 cubic centimeter is the amount of space that is required to hold 1 milliliter of liquid. The abbreviation CC is not recommended because of the danger of misreading it as 00, but is occasionally still found on prescriptions and medication orders. The preferred abbreviation is ML. The abbreviation MG for microgram may be misinterpreted as milligram, causing a 1,000-fold error. The preferred abbreviation is MCG. It is important to have a general idea of the weight, volume, or length of a unit. Most people in the United States are familiar with household but not metric units. The following comparisons can be helpful. So a gram is about the weight of 2 large-sized paper clips. A liter is about the size of a quart container. A meter is a little longer than a yardstick. And fractional parts of numbers in the metric system are indicated with decimals. A 0 called the leading 0 should always be placed before a decimal when the number is less than 1 to prevent confusion and a possible error and misinterpretation. So you would never write like 0.5, it would be 0.5, or 0.2, it would be 0.2. For instance, 0.25 milligram might be misread as 25 milligram if the measurement is not written as 0.25 milligram. A potential error would be 100 times too much medication being administered to a patient. Also, no zeros called trailing zeros should be added to the end of a fractional portion following a decimal point. For instance, to prevent errors, 2.50 milligrams should be written 2.5 milligrams, and 1.500 liters should be written 1.5 liters. Zeros found at the end of a number to the right of the decimal point may be removed without changing the value of the number. The following depicts the weight measurements used in pharmacy from largest to smallest. There's 1,000 unit difference between each of the following measurements of mass. The apothecary system is one of the oldest systems of measurement, first being used by an apothecary, which was an early pharmacist. This system is gradually being replaced with the metric system. In ancient times, a minim, which was a drop of water, was considered to weigh the same as a grain of wheat. Therefore, the basic unit of liquid in the apothecary system is a minim, and the basic unit of weight is a grain. Apothecary measurements of volumes such as minims, fluid drams, and fluid ounces. And you can see all the different symbols. So we have the M there for minims, the fluid drams, it's FL with that little bigger looking 3, and then fluid ounces, which is FL with that 3 with a Z on top. And they're still found on some pharmacy bottles and medication dispensing cups, even though the use of these measurement systems is discouraged. So if you look at the amber bottles for liquids at your pharmacy, you'll see that they do still have the apothecary symbols on them. Apothecary symbols are found on the ISMP list of error-prone abbreviation symbols and dose designations. Although the metric system is preferred, the apothecary grain is still used with some older medications, such as nitroglycerin sublingual tablets. In the apothecary system, lowercase Roman numerals are used for expression of numbers 10 and below, rather than Arabic numerals as found in the metric in household systems. The Roman numerals should be expressed with lines placed over them to tie them together, such as I, 2, 3, 4, 5, and 6. You can see those. And lowercase i's are often expressed with the dots above the line. Arabic numerals may be used for numbers higher than 10, except for 20 and 30, for which Roman numerals are required. Over the years, the use of the line over the Roman numeral has gradually diminished, but using it is correct. Fractions other than 1/2, which is SS, are expressed using Arabic numerals. Roman numerals and Arabic numerals are never used together in one measurement, so when using a fraction other than SS, use Arabic numerals for the whole number as well. Therefore, 7 3/4 would be 7 3/4, not VII 3/4. Decimals are not used with the apothecary system. The unit abbreviation is written first with Roman numerals placed to the right of the unit of measure. So this is the only one that has the units first and then the number after. And then table 4.6 shows this equivalence in the apothecary system. And then here's just some important points to remember about the apothecary system. 3 measurement systems are used in the field of medicine in the United States. The household system is used on a daily basis in homes. However, using the household system for medication dosing provides only approximate measurements. The use of actual measuring spoons as opposed to individual flatware can help decrease the variation. The metric system is the standard unit of measure throughout the rest of the world. Most medications are designated in the metric system today. The use of the apothecary system is discouraged. This system is used occasionally for some medications. The measurements for length, weight, and volume must be learned for conversions within and between the systems. And we will do a mix of the um, post-test questions since there are no examples in this chapter. All right. As promised, I said we would go over some of the post-test problems since there was no examples in chapter 4. So remember that we use decimals for the metric system, fractions for the household, and fractions and Roman numerals for the apothecary. So when we see 36 kilograms, we're going to write the number first and then the symbol after. All right, number 2 is 5 4/10 gram. So we would have to turn this into a fraction first to change it to a decimal because we have the metric system grams, and we need decimals. We cannot give the answer as a fraction. So just look at this. I'll write it out as a fraction. So we have 5 and 4/10. So we have this mixed number and we want to turn it into an improper fraction so we can get a decimal. So we go 10 times 5, which is 50, plus 4. So 54 is going to be my numerator and 10 is still going to be my denominator. Now to get my answer in decimals, I am just going to do 54 divided by 10, which gives me 5.4. And that is our answer. You shouldn't see any problems like this on your 3 teaspoons. So of course this is household, so we do our number first and then our symbol after. 9 tablespoons, same thing. 5 grains. So this is apothecary. So remember with apothecary, we use the symbol first. So GR, and then we use Roman numerals. So 5 in Roman numerals is V. So the answer is GRV. Number 6 is 10 fluid drams. So first we need to do the dram symbol. Sorry, I'm trying to draw it as best as I can. And then we need to put 10. So we can't just do this because we are working with the apothecary system. So we would need to put that as a Roman numeral. So that is going to be that little 3 looking thing with X. 6 pints would just be 6 pint, and 125 micrograms would be 125 mcg.